Industrial plants like yours use many different types of pumps. One of the most common types of pumps that plants depend on is a centrifugal pump. Centrifugal pumps use centrifugal force to move process liquids. One basic requirement that affects the operation of all centrifugal pumps, large or small, is that they must be primed. In other words, the pump casing and suction line must be completely filled with liquid before the pump is started. If a centrifugal pump isn't primed, it won't operate properly. Now, some centrifugal pumps stay filled with liquid when they're shut down. These pumps are often called self-priming pumps. Sometimes they have components, such as check valves, that maintain the prime after the pump is shut down. In other cases, the system is built so that liquid does not drain out of the pump after it is shut down. So, with some pumps, you may not have to prime the pump, but this isn't always the case. In some cases, it may be necessary to prime the pump manually. A common way to prime a centrifugal pump is to open the pump suction valve and the vent valve. Opening these valves allows liquid to fill the pump and air to escape. In order for this to work, however, either the level of liquid to be pumped must be higher than the casing of the pump, or the suction pressure must be great enough to force the liquid into the pump. If the pump is handling a hazardous liquid, the casing vent should be piped to equipment that will prevent the escape of hazardous liquids. If the liquid level is below the pump casing or the suction pressure is too low, a variety of devices can be used to prime the pump. In some applications, a vacuum system is used to draw air out of the pump. By drawing air out, this system primes the pump. Once the pump casing is full of liquid, the vent valve is shut, and then the pump driver is started. Centrifugal pumps can be started up and shut down in a number of ways. The procedures that are used often depend on the type of centrifugal pump you're working with, the type of driver that's used, why the pump is being shut down or started up, and company operating procedures. We're going to look at some basic steps that can be followed to start up and shut down most centrifugal pumps. But keep in mind that you'll always need to follow the specific procedures used by your company. You should also be aware of the effect that starting or stopping the pump will have on the process. This is the pump we'll be using. It's a single-stage centrifugal pump, and it's part of a system that supplies cooling water to a facility. The pump is driven by an electric motor. Water flow into and out of the pump is controlled by isolation valves. The pump shaft is sealed with a mechanical seal. One of the first steps in the startup procedure is to check the pump's suction pressure. In this case, that's done by checking the level in the system expansion tank and making sure that the pressure in the expansion tank is correct. On this pump, the expansion tank ensures that there is sufficient suction head for the pump. Also, the pump and its driver should be checked for obvious signs of damage. On some pumps, auxiliary equipment may have to be checked before startup. For example, the lubrication systems must be checked. Also, sealing liquid to a mechanical seal may need to be lined up to the seal. Once the preliminary checks are done, the next step is to line up the valves in the cooling water system. This step is based on the pump startup procedures, which specify the valves to open or close and the proper order. On this pump, the suction isolation valve is opened. Opening this valve provides a path for liquid to enter the pump. The operator then starts the pump and checks it to make sure that it's operating properly. These checks often include checking the pump's suction pressure and discharge pressure, checking the bearings for excessive vibration or overheating, listening for unusual noises, and checking the pump for signs of leaks. Venting the air from the pump while the suction valve is open will fill the pump with liquid. This step is often referred to as priming the pump. The discharge valve on this pump remains open when the pump is shut down, so it's already in the proper position to run the pump. On other pumps, however, the discharge valve may be shut when the pump is shut down. In these cases, the procedures may say to leave the discharge valve shut, to partially open the valve before the driver is started or to fully open the valve before the driver is started. In our procedure, the discharge valve remains open when the pump is shut down, so there is a flow path for the cooling water into and out of the pump. At this point, the control room should be informed that the pump is ready to be started. The operator then starts the pump and checks it to make sure that it's operating properly. These checks often include checking the pump's suction pressure and discharge pressure, checking the bearings for excessive vibration or overheating, listening for unusual noises, and checking the pump for signs of leaks. On some pumps, additional checks may have to be made to be sure that the pump is operating properly. For example, it might be necessary to check the amount of current that the motor is drawing. Okay, that's a basic centrifugal pump startup. Now let's look at a centrifugal pump shutdown. When the pump is no longer needed, the operator receives permission and shuts off the pump's driver. The running pump's discharge pressure should be checked to see if it's normal. If there's no drop-off in pressure, the pump switch is successful. Once the pump is stopped, its suction isolation valve is closed. In this example, that's all that's required to complete the pump shutdown. On some pumps, the suction and discharge valves are both shut when the pump is shut down. This will completely isolate the pump from the system.